Hello everyone, my name is Ajitesh and in this video I'm going to talk about what is cross entropy loss function. So without further ado, let's get started. In this video, we are going to learn about the concept of entropy, and then we'll learn about what is cross entropy, and finally we'll learn about what is cross entropy loss function. Before we go on to understand the concept of cross entropy, it's very important to understand what's entropy. Entropy can be defined as the measure of randomness in the system's expected behavior. In other words, it can be defined as the measure of uncertainty or the surprise in the system's expected behavior. For example, if let's say we have bought a car. As we have bought a car, the system's expected behavior will be near to ideal. But as the time progresses, the expected behavior of the car would be little more random and uncertain from the perspective of issues that shows up on the car. So as I mentioned earlier, it is the measure of randomness. So if there is a less randomness, the entropy will be less. If there is a more randomness or uncertainty, the entropy will be more. So when we have bought the car, there is a less randomness in the car's behavior and it works as expected, so the entropy will be less. But as the time progresses, the randomness or uncertainty in the behavior of car increases, so the entropy of the car would be higher. Now let's understand the concept of entropy with respect to the random variable and probability distribution, because this will be key to understanding the concept of cross entropy. So when we say the system expected behavior, the system behavior can be associated with the random variable and the different states that the system behavior can take based on the different scenarios is what can be called as a different state or different value of this random variable. So in the initial stages, when we have system in place, or when we have acquired the system, or when we have actually bought a car, for example, we have seen the system's behavior or the car behavior in the different scenario will be near to ideal and it will have different probability distribution. But as the time progresses, the probability distribution of the car behavior will change. So now we saw that entropy can be related to the probability distribution of the random variable. From that perspective, a skewed probability distribution has less randomness, so it will have less entropy. And a probability distribution like a normal distribution will have more randomness, and so it will have higher entropy. Let's go now and learn about the concept of cross entropy. Cross entropy can be defined as the measure of difference between two probability distribution. A moment back, we have seen that entropy can be related with the probability distribution of a random variable, and in turn, the probability distribution of the system expected behavior. So if there is a probability distribution representing the system behavior at one point in time or in one scenario, and if there is a probability distribution of system behavior at another point in time or in another scenario, if we find the difference between these probability distribution, we come to have a concept called cross entropy. Now, greater the difference between the probability distribution or the system behavior, greater is the value of cross entropy. Let's understand it with an example. Let's say that we have a random variable which represents the salary range based on work experience. Now, in the actual world, there will be a probability distribution that represents that how much is the salary range based on a given work experience. Let's say we have built a classification machine learning model that makes a prediction of the salary range based on the work experience. So there will be a what is called a predicted probability distribution related to this classification model. Now, the cross entropy can be defined as the measure of difference between the true probability distribution that represents the salary range based on work experience versus the predicted probability distribution from the classification model representing the salary range based on the work experience. Now let's understand the cross entropy loss function. The cross entropy loss can be defined as the difference between the actual probability distribution and the predicted probability distribution of a classification model. So a great classification model will have a lesser cross entropy loss and vice versa, meaning if our classification model is not performing in a right manner, there will be a greater cross entropy loss. So when we are training a classification model, the objective will always be to minimize the cross entropy loss. Now at the time of training, we go and define a function representing this cross entropy loss. That function is called as cross entropy loss function, and the training objective will always be to minimize the cross entropy loss function. Now let's take a look at what is the formula of cross entropy loss function. As we have seen a moment back, that the cross entropy loss can be defined as the difference between the true probability distribution and the predicted probability distribution. That can be represented using this formula, which is summation of probability distribution of actual probability distribution multiplied by the log of the predicted probability distribution. Alright, so that's what I had to discuss in this video. Hope you have liked this video. Thank you very much for watching this video. If you have any questions regarding cross entropy loss function, please write them in the comment and I would respond as soon as possible. Until next video, have a good day and thank you once again.